Chapter 7, Section 3 is entitled Bar Graphs and Histograms. And in this section, our objective is to display and analyze data in bar graphs and histograms. We'll begin with the vocabulary that we'll use throughout this presentation. The definition of a bar graph. A bar graph is a graph that uses vertical or horizontal bars to display data and compare data. A double bar graph is a bar graph that compares two related sets of data. And a histogram is a bar graph that shows the frequency of data within equal intervals. Again, a bar graph is a graph that uses vertical or horizontal bars to display and compare data. A double bar graph is a bar graph that compares two related sets of data. And a histogram is a bar graph that shows the frequency of data within equal intervals. So in this first question, we're simply going to look at the bar graph and answer some questions about it. And as you can see, what's a little bit different from the bar graphs that you're probably accustomed to is that the bars run horizontally here. Usually in a bar graph, especially ones you've seen in school, usually the bars run vertically, but it's no consequence here to us. It's just formatted differently. So the question being posed based on the bar graph is which language has the least number of native speakers? So really they're asking us which bar is the shortest. And you can see from the dashed lines there that although several of the bars are close, the Spanish bar concludes furthest to the left, so it's the shortest bar. And with the bar for Spanish being the shortest, Spanish has the least number of native speakers. About how many more people speak Hindi than Spanish. So now they're asking us to calculate the difference between two bars, or in other words, subtract the numbers that associate with those bars. And as you can see again, the Hindi and Spanish bars are not all that far off from each other. The Hindi bar is around the 375, and in this case that would be million mark, while the Spanish bar is probably a little bit closer to the 300 mark, maybe just past it a little bit. And as you can see, that's indeed the approximation they've used here. They've used the 375, and in this case 325 million, to approximate a difference of 50 million. So about 50 million more people speak Hindi than Spanish. Number 2, the table shows the highway speed limits on interstate roads within 3 states. Make a double bar graph of the data. So the first step here is asking me to choose a scale and interval for the vertical axis. What they're asking us in simple terms is what number system do you want to use going up the y-axis, the one that runs up and down. As you can see in this particular problem, I've chosen 15, increments of 15. You can choose any increment you want, but you have to be consistent. You can't say, I want to go up by 20, and then I want to go up another 15 to 35, and then I want to go up 10 to 45, and then I want to go up 20 again to 65. Once you decide what you want to increment by, you have to increment by that amount the whole time. And that's indeed what you see done. We've gone up by 15s the whole way. Now, what we're making here is a double bar graph. So you're going to have one set of bars that represents the urban numbers and another set of bars that represents the rural numbers. And as you can see, what we've done here in this graph is that the red bars represent the urban numbers and the green bars represent the rural numbers. In other words, the bar that's on the left for each state represents urban, and the bar that's on the right for each state represents rural. So as you can see, what we've done to start is we've labeled tops of the bars at 65, as in 65 miles per hour for Florida, 70 for Texas, and 55 for Vermont. And then we've gone back and repeated that process for the rural numbers, 70 for Florida, 70 for Texas, and 65 for Vermont. And then we've made our bars. Notice that the bars for each state touch one another, which is the correct way to make this. However, the bars from different states do not touch each other. There's a wide gap here, which is the correct way to make the double bar graph. Okay, so as you can see now, the graph has changed just a slight bit from what you saw on the previous slide, but not dramatically, in that we've added some components here. One of the properties of a well-prepared graph that we've discussed is labels on the axes. And as you see, this bar here, with this line, the x-axis is now labeled states, and the y-axis, the one that runs up and down, is now labeled speed limits. Another one of the properties of a well-prepared graph is a title. So as you can see, we've now titled the graph with urban and rural speed limits. And we've also included what they discussed in step 4, a key. The key tells me how the different bars are represented, in that the red bars represent the urban numbers and the green bars represent the rural numbers. And that would be a completed, in this case, double bar graph. You would have many of those same properties on a single bar graph, except for the key, because in a single bar graph there is no comparison being made, so you don't need to represent the bars in any different way because there would be none. Okay, let's take a look at example 3. We're going to switch the topic here and go to a histogram. Now, a histogram will not look dramatically different from the bar graph. What's different about a histogram from a bar graph is that the bars will abut each other. In other words, they will touch each other. There will be no gap between the bars. The histogram also requires the creation of a frequency table, and we've done that already in chapter 7. You have to make the frequency table before you can make the corresponding histogram. So if you've forgotten how to make a frequency table, it would probably be a good time to go back and review that section if you need to. So the table shows the number of hours students watch TV in 1 week, and where to make a histogram of the data. So remember, when we make a frequency table, which is what they're talking about in step 1, we need to do that with even-sized intervals. And as you can see, what they've chosen here is the 1 through 3 group to be one set, the 4 to 6 group to be a second set, and the 7 to 9 group to be a third set. And as you can see, each one of those sets has 3 components in it, which is how we get our even-sized intervals. As you can see, they did not make the tally marks in this frequency table because that's kind of already done for us over here. We just have to do a little bit of a summation. So we see in the 1 through 3 groups, if we total all the tally marks here, there are 15 tally marks. In the 4, 5, and 6 groups, 17 total tally marks. In the 7, 8, 9 groups, there is also 17 total tally marks. And we'll now transfer that data over to our histogram. When we do that, we're going to need to choose an appropriate scale and interval for the vertical axis. The greatest value on the scale should be at least as great as the greatest frequency. We're going to draw a bar graph for each interval. The height of the bar is the frequency for that interval. Bars must touch but not overlap. So as you can see, on the right side now, your histogram has appeared. Again, it does not really look any dramatically different than a bar graph, except for the fact that the bars touch one another. In the 1 through 3 group, we got all the way up to 15. The 4 through 6 group up to 17. The 7 through 9 group is also at the same marker. The only reason you see different colors is to delineate the differences between the bars, so you can see which one is the 1 through 3, the 4 through 6, and the 7 through 9 more readily. As you can see, making the graph, I decided to go up by 3s on the y-axis. And as we talked about just a minute ago, you have to choose an even-sized amount to go up by and go for that amount the whole time. In that this time we decided to go up by 3s, and I went up by 3s the whole way. Step 4 asks us to label the axes and give the graph a title. One of the things that's slightly more convenient perhaps about a histogram is that you can always go with the labels interval and frequency, because that's what that will always be. It will always represent those even-sized intervals and how many times those interval numbers appear. The title comes back to the problem, what it was about, and in this case it was about student TV viewing, so we labeled it student TV viewing. Okay, so let's conclude with looking at this final question here, which is asking us to use the bar graph to answer the question about how many more pounds of apples than pounds of grapes were eaten per person. So they're again asking us to find a difference between the apples bar and the grapes bar. Well, as you can see, the apples bar is about midway between 15 and 20, so roughly 17 and a half, while the grapes bar is also about halfway between two bars, halfway between 5 and 10, which is about 7 and a half. So if we subtract 17 and a half and 7 and a half, we find a difference of 10. So there were about 10 pounds more apples eaten than grapes.